So we're going to start up where we left off yesterday. We did many of these types of problems. We didn't do anything from the book yesterday. But we looked at only the problems we looked at your homework that did not have a number in front of the squared term. We looked at x squared or p squared. But we did not look at anything that had like a 2x squared or a 9x squared or something like that. So today your homework is going to be do actually 32 to 35. I'm going to show you one little extra step and also 54 and 55. What happens when there's a number in front of the square term? First, let's start with just a refresh from yesterday. The whole idea was to get our equations to be on a binomial squared, because then we can just take the square root of both sides, plus or minus and do square root. And this part you don't need to write down, so I'll review, just refresh your memory. And then square root of 25 is 5, add 3 to both sides, and you have your two answers, 3 plus 5 and 3 minus 5. And always get those answers. If you can get the answers, always get them. I see some people on your homework, you'll kind of stop here. You keep going. Unless this is a radical, like radical 5, then you can't keep going. But if this is a regular 5, rational 5, you can get your two answers. The next step from here is, that what if it's factorable? Right? Sometimes we can just factor trinomials like 2 and x. What two numbers multiply to 1, add to 2? That'd be 1 and 1. So y plus 1 is y plus 1. It's the same as y plus 1 squared. And again, we can take the square root of both sides and finish it up. Now, this isn't the usual situation where you can just, right from the very beginning, take the square root of both sides, but this is where we're trying to get to on every one of these problems. And get your two answers if possible. 3 and -5. Okay. So we observe this pattern that if we had y squared plus 6y plus 9, it factors to y plus 3y plus 3, which is y plus 3 squared. And we saw this over and over and over, which is useful because that means, well, if we don't know the number, we can still find it through this pattern. If I take half of b, which is 6, divided by, take half of it, you get 3. And when I square this number, I get c. So if I have anything missing, I don't know what it is, half of negative 10 is -5. Okay. So I know it should be -5. -5 squared is 25. So I know what number it should go to in case I'm missing. So we use this idea on many of your problems and said, well, half of -6 is -3. -3 squared is 9. But if the wrong number is there, we simply just move it out of the way. Then we complete the process and put the number there that's 1. So we had half of -6 is -3. -3 squared was 9. And we did that in both sides. And then we could go ahead and solve it. Take the square root of both sides. So I'll review. This is what we did yesterday. Now, there is this kind of inside process. Again, take half of b. That's what goes here. The same thing works even if it wasn't a nice number. So if it's like -3, half of -3 was just -3 over 2. So it's okay for fractions. Leave them as fractions. Leave them as fractions. And if you square that, make sure you square the top. You get 9. Square the bottom, you get 4. If you need to, you can write it as 3 over 2 times 3 over 2. It might be more clear why it's 9 over 4. But we don't want to make like a little error right here and just put, oh, it's 9 over 2 or something. It's kind of silly because it'll ruin the whole problem just for a little mistake. So 9 over 4 would be the c value. So whenever you get fractions, leave them as fractions. It's okay to reduce a fraction. If you've got like 16 over 6, something like that, definitely reduce the fraction. But don't change it to a decimal. Alright, so here's the full problem that you guys did yesterday. We looked at the c value, determined well, is this half of this number then squared? It wasn't, so we got it out of the way. And then I told you to do it this way. I'll leave a space here. Set up the parentheses, the variable, the squared, equal sign. Set everything up. I'm a big fan of just setting up the whole problem and then just putting in the numbers all in one time. So we started here and said, what's half of negative 8? 4. Yeah, negative 4. And we went up, squared it, and you got 16. And this number is always positive because you're squaring a number down here. So it doesn't matter if this is a negative or a positive. This is always coming out a positive number. Over here, same thing as the other side. And then you simplify. Negative 7 plus 16. So you win this clockwise rotation, starting bottom left and go all the way around. And then it's already set up to square root both sides and finish. Get your two answers. Put it in the parentheses, you have the braces there, 1 and 7. If you're really eager and you have time, you can always check your answers, 1 and 7. 1 squared minus 8 plus 7. Does it equal 0? Yes. 7. 7 squared minus 8 times 7 plus 7. Does it equal 0? Yes. You always do a check. Many of you looked on your calculators, figured out how to store variables on calculators. So we just have to type this in once, and we should change the values from x equals 1 to x equals 7, and you should get the same number. Okay, so the big question is, the fraction. Yeah, we'll review in fractions. Let's talk about this. Half of negative 7 is negative 7 over 2. Square root on both sides. Nothing. 49 over 4. 7 times 7 and 2 times 2. You got to square the top and the bottom of that. I just want you guys to be comfortable with fractions before getting your answer. Don't do any steps different, or say it's harder, or say anything. It might take a little bit longer, it's more writing, but not more difficult. It takes a little longer. Alright, so here's where you want to start writing this down, because we have a number other than 1 for A. Good news, bad news. It's basically the same thing. It's going to be one little extra step. Bad news is, yeah, there's a bunch of fractions, so it's going to take a little bit longer. It's not more difficult. Okay, it just takes a little longer. Do not write small. I know some people, like when they get fractions, they want to write real small and tiny, and just they want to fit it in on a paper in a certain amount of space. And think about it. You're trading, space on a paper for your accuracy. If you're writing so small and you make a mistake that you can't read it, it's really not worth it. So write a little bit bigger. Please don't make a mistake. Let's see. So here's what we're going to do. We're going to start the same way. Half of 7 is 7 over 2. 7 over 2 squared. That doesn't equal 4. It's a minus 4 anyway, so we know that can't be the right seek value because it's negative. So just like before, move it on over. Get it out of the way. So here's the only difference. After we've done that 4 on the other side, now that we have a number in front of the x squared, we're just going to go through and divide by that number. So in front of the x squared is 2, you divide everything by 2. But of course, distribute on the left-hand side. That's the only thing you do there. That's why we're only really doing like 5 or 6 of these, because it's the same thing you did yesterday, you just have more fractions. Alright, so we end up with 2's cancel out, and then just leave it as 7 over 2. No decimals, leave it as 7 over 2. 4 over 2 equals 2. Set up all the parentheses, equal sign, the second power, the variable inside, set that all up. Alright, here's magic time. 7 over 2 times a half. What is half of 7 over 2? You need to write down your paper, write 7 over 2 times 1 over 2. What do you get? 7 fourths. Basically multiply the denominator by 2. That's half. Half of 7 over 2 is 7 over 4. You're dividing the halves, each divide those. square of 7 over 4. What is 7 over 4 times 7 over 4? 49 over 16. That's what we add to both sides. Both sides. Now, in your calculator or on your paper, go ahead and type in 2 plus 49 over 16. Using common denominators on paper or just on your calculator, either way. And many of you will get a mixed number. If you hit shift and then the fraction button, it will give you the improper form. We want the improper fraction. So hit enter. If it gives you like 6 and something change, then you can hit the shift fraction button. It'll give you the correct improper fraction, which is 81 over 16. And if you did the old-fashioned way, you just converted 2 to 2 over 1 and multiplied top and bottom by 16 to get common denominators. So we added 32 and 49 and you got 81. But hopefully you just use your calculator so there's 0% chance of arithmetic error. The last thing you want to do is miss an algebra problem simply because you forgot a common denominator or something from the 5th grade. The common denominators in the 5th and 6th grade, so we don't want to make that mistake. Okay. And from that point on, solve it. Square root both sides and solve it. So here we go. This one's kind of nice because you can take the square root of the top and bottom. Or I should say the top and bottom. Because the top, sometimes you can't. The bottom, you can always take the square root of the bottom. It always comes out to a nice number. So we end up with square root of 81 is 9, square root of 16 is 4. And it's the same old steps that we did before. Oops. We get negative 7/4 plus or minus 9/4, which just means two answers. Negative 7 plus 9, 2. Negative 7 minus 9, negative 16. And simplify always the two answers. So if you have a perfect square radical, means your answers on square roots, you should have two numbers in your final answer. Only time you have the plus or minus in the answer is if the radical is already simplified, like plus or minus root 2, plus or minus root 15, something you can't actually simplify. So if that's going to be the process today, I mean 90% of that is the same thing you did yesterday. It's just that second step where we divided by 2. We didn't have to. Yes, there are a lot of fractions. Just write neat, stay organized. Know how to take half of a fraction, multiply it by 1/2. Know how to square a fraction, square the top and the bottom. Square the whole thing. That's the big picture. Any clarifications on any of these steps? I'll be walking around asking you guys about your calculator later if you know how to use it, especially that 2 plus 49 over 16. That step comes early in the problem, so if you do that step wrong, everything else after that is wrong. You know, when I'm grading it, it'd be like, well, they got the first 3 steps wrong, but they missed the next 7. So you get a 3 out of 10 on that problem, simply because of 5th, 6th grade arithmetic. I don't want that to be a problem, so I want you to know how to use your calculator really, really well. All right, so let's just watch this one. Once again, half of negative 7, negative 7 over 2. Go up, square it, so we can be positive. 49 over 4. 7 squared, 2 squared. Same thing on both sides. Okay. Punch in your calculator. You notice here, when we take the square root of this, we can't take the square root of 57. It doesn't reduce. You can take the square root of the bottom. Right? 2. Bring it up here. And we can finish the problem by adding 7 over 2 on both sides. Notice how it looks just like a quadratic formula answer. 7 plus or minus is square root of 57 over 2. It's not a coincidence. We can solve this by doing the quadratic formula. Negative b, the opposite of b would be, if this is negative 7, it would be positive 7. That's what we get there. All over 2a, all over 2 times 1 is 2. If we did b squared minus 4ac, we get 49 times 4 times 1 times negative 2. So it would be 49 plus 8, 57. So of course we can solve this using any method, and we should get the same exact answer. So at this kind of answer is when you just stop and say, that's as far as I can go. I can't reduce 57, and that's all. But if this was like 64, you have to keep going and actually get the 2 rational answers. All right, so let's show what you're going to be doing. Like I said, you're going to be doing (32 to 35) right here, but you're also going to be doing something else. So let's see. Write this all down. We're going to do 5-5, I believe it is. We're going to be doing 5-5, page 271 maybe? 73. 73, okay. So we're going to be doing 32 to 35, and then also 54 and 55. Okay. In addition to that, this is only like 6 problems. In addition to that, you're going to be doing solving with 3 methods. Solving with 3 methods. So what that means is that I'm going to show you right here. I want you to take number 1, number 2, and number 4, skip number 3, and I want you to solve those using completing the square, quadratic formula, and factoring. Each one of these and solve it using all 3 methods. So I'm trying to reiterate that so far in the past 2.5, 3 weeks, we've only learned how to solve 1 problem. Each of these could be questions from your very first homework or from your homework last night. It's just that we're using a different method from day to day. But the question hasn't changed at all. We haven't said like, well, find the x-intercept one day, and then next day let's find y-intercepts. Or one day we're doing like 2 equations, 2 variables, and the next day we're doing 3 equations, 2 variables. We're really just doing the same question using different methods. And we could throw in the 4th method, which is graphing, but we're not going to be graphing. So like on number 1, you're going to have to complete the square, quadratic formula, factor. Number 2, same thing. So it's really a total of 9 questions. They're all review. It's just a way of reviewing everything we've done so far for this chapter. Okay. So make sure you write these down. X squared minus 2x equals 8. X squared minus 6x plus 9 equals 0. And then skip 3. And then 4 is x squared minus 4 equals 0. Here's what your homework should look like on this portion. So I want you to write these in columns. For each problem, have a complete the square, the quadratic formula, and the factoring. And of course, you should be getting the same answer in each method. After all, right? After all, you're there, 4-2, there, 4. You've only solved 1 problem. So of course, if you solve it, you should get the same answer, regardless of which way you actually solve it. So like on the one, this is the one you're not actually doing, but I'm showing you the format. Also, I want you to see some other things. Notice how long the quadratic formula is. I know many of you like it, and you're like, that's your go-to. Look how long it is compared to the other two methods that we know how to do. So this is one of those things that, like, you know, the test was really hard, I ran out of time. How come, you know, other people finished like 20 minutes before me? This is so long. If you're using quadratic formula for every single one of them, of course it's going to be too long. So part of all these methods is, well, now that you have them all, when do you use each method? When's a good time to use quadratic formula? And when's a good time just to factor it? I'll show you some of the answers for your homework. And here's the second one. Look how fast it is to factor it. What two numbers multiply to 9, add to -6? Oh, -3, -3. The answer is 3. So you could go through all this work right here in the quadratic formula just to find out the same thing. The complete the square is actually pretty simple because half of -6 is 3, squared is 9. So it's already set up for completing the square. Really nice, really quick with completing the square. So the idea here is to see these side by side and see, look how much shorter this is if I just factor it. I better not be addicted to just doing quadratic formula everything because there's so many mistakes that happen in the square root and all these other problems. So if I can, this is probably faster and easier. You know, oh, that person that finished their test so fast, they must be really smart at this. They can do the quadratic formula so fast. Not really. They're probably not using it like you are. They're probably saying, this is the last thing I want to do. Last thing I want to do is do the longest method that has the most mistake potential. They're probably doing this. They're doing the same thing in a quarter of the time because they know to use this method over this one. And that's why I want you guys to do all these methods side by side to see, you know, when is it worked in quadratic formula. Short answer is, factoring, it only works sometimes if you have rational roots. If one of our answers are like square root of 57, like that last one, you can't get that by factoring, and you have to do complete the square. And complete the square of what we're doing today, where you have to divide by 2 and everything. This one's nice, because if you divide by 2, it's still nice numbers. But when you get fractions, it's not really worth it. So completing the square is really nice when a is equal to 1. Quadratic formula is nice for like anything else. If you have some really big numbers, or things that might give you a lot of fractions, quadratic formula is a little bit long, but we don't have a bunch of fractions focused on them. So you got to know the pluses and minuses of each of the methods. Especially like on the last solving this one, add 4 to both sides to the square root. Get plus or minus 2. Look how much work it is for the quadratic formula. Just to get down and have the same exact thing. Not worth all that work. And you could just factor it. X minus 2, x plus 2. Same thing. Alright, so let's get started on your homework. Let's go back to the book work. I want to do the first one with you to see if you started. And then I'll let you work the rest of the period. Title it 5-5, page 273, 32 to 35, side 40, 54, 55. Write down the first problem, 32. And let's just go through the steps one more time. And then you have a nice clean example on your paper as you're doing these. Always refer back to it. Alright, so first step is everything that we've done before. What's half of 3? 3 over 2. 3 over 2 squared is some fraction. This is a minus anyway, so anytime you have a negative here, you know you're just going to have to move it out of the way. It has to be a positive for this whole thing to work. Well, this is your homework, so you're going to do it on your homework page. Good. And the second part is what we actually went over today that was somewhat new. Whatever number we have in front of the x squared, we need to divide by that on both sides. That's the little new part. Notice how I'm still leaving that space here? I'm going to need to put in the C value in a second. Distribute that with both of these. We have x squared plus 3 over 2x. Leave as a fraction. Leave the space. Leave everything as a fraction. Set it all up. The parentheses, the square, the equal sign, the variable. You need to put the sign here because I know it's always the same as b. The sign is always the same. So if this is positive, I know this is negative. All right, half of 3 over 2 is 3 over 4. 3 over 4 squared equals 9/16. Square of the top, square of the bottom. Same thing on both sides. Notice I'm going this clockwise rotation. So same thing on the top. Both sides. These are always the same right here. I'm just adding the same thing to both sides. Either put in your calculator or just compute by hand. What is 5 over 2 plus 9 over 16? $49 over 16. Again, if you're not getting 49 over 16, if you're getting some mixed number, I can come show your calculator how to actually say 49 over 16. So you do not want any errors here. That's a big thing. I don't want you kind of guessing or maybe you got it right. I want to make sure you're getting this arithmetic correct. Okay, now we have something squared equal to a number, square root both sides. We have x plus 3/4 equals plus or minus 7 over 4. Square root of 49 is 7, square root of 16 is 4. Move that 3/4 to the other side, put it in front of plus or minus. X equals negative 3/4 plus or minus 7/4. Now at this point you can get your two answers. Right here you have an option. You have the same denominator. If you prefer, you can write it kind of like you see in the quadratic formula as all over the same denominator if you want to. So since they're the same denominator, you can just say, oh, it's negative 3 plus or minus 7 all over 4. So, optional. Negative 3 plus 7. 4. Negative 3 minus 7. Negative 10. So we have 1 and negative 5 over 2. Now, look at this thing as a whole. The part in red, that's the only thing that's new today. Part of the red, right here. The fact that we have to divide by 2, that's the only thing that's new. Everything else you do exactly the same. If anything, focus on your organization, your neatness, so it's easy to follow and legible. Also, we had a little issue with last night's homework that I just started looking through all the answers, and I noticed that there was way too many people that were missing odds. Why should you not be missing any odds?
In the back of the book?
In the back of the book. There's some people, again, you're doing that violating that cardinal rule of math is check the back of the book. Are you concerned about finishing, or are you concerned about doing it correctly? Are you concerned about having the homework done, or are you concerned about passing the class? You need to be concerned about passing the class. That way you'll actually check all your answers when they're available. That's why I give you the odds, so you know if you're really doing it correctly. But if your goal is just to write something down to get some whatever points just to say you're done, and then who cares if you're getting it right, remember you don't have the right to ask me later, how can I raise my grade? The quick, easy answer is start caring if you're doing them right or not. So it's kind of like I gave an example before with mechanic. You take your car to mechanic, you expect them just to do it correctly. You wouldn't pay them if they did it all wrong, and even if they said, "Well, I worked on it for 3 hours," doesn't matter. It's wrong. You don't pay them. You don't get anything for trying for 3 hours and doing it wrong. You don't pass classes for trying for a whole year and then saying, "Well, I tried all year." You don't pass. You have to make sure your priority is checking the odds to make sure you're doing them right. Chances are you could have made a mistake on the very first problem, found, oh, I did it wrong, and then go through, find out what your mistake is, and now you don't make the mistake for the rest of your homework. But if you don't check as you're going along, you might just keep on making that same mistake over and over and over, even though it's something super simple that you can fix on your own, by yourself, with no help. But if you don't bother checking, you'll never know. So it turns into a lot of extra work because you have to go back and redo so much, when just checking as you go would, take care of that whole issue. So I'm going to pass back a few of those homeworks, and you're going to have to redo them all that are wrong. So everything that you didn't check, those odds, you have to go back and fix them all. You can't just write down answers and say you're done. All right, so let's have you